Alright, my name is Miguel and I'll be going over how to solve this problem. Here we're given this differential equation and we're asked to solve via the method of undetermined coefficients. So the first thing that we're going to want to do is we're going to want to solve for the complementary solution, or solve the complementary equation and get the solution for that equation. So what we're going to do is we're going to set this differential equation and we're going to set it equal to 0. And once we set that equal to 0, we can solve for it using the characteristic equation. So here, setting up the characteristic equation, r squared plus 4r, we solve for r using the quadratic formula, and we get that r equals 2i. So we can rewrite that as lambda plus 2i. Here, lambda equals 0, and w, or omega, is equal to 2. So recall that the solution, the solution form for complex conjugate roots is this, which I wrote right over here. Here, like I said earlier, we found out that lambda is equal to 0 and omega is equal to 2. So we can go ahead and plug in lambda and omega into this solution form for the complementary solution. And we get that the complementary solution is actually yc equals to c1 times cos of 2t plus c2 sine of 2t. So already, just by looking at this complementary solution, we can tell that cos 2t and sine 2t are solutions to the complementary equation. And knowing this information, we can use it and apply it to this theorem that we have right over here, which says that if cos and sine are complementary solutions to this, they are the complementary solution to this differential right over here, then we can determine that ax is equal to this form right over here, this expression, and bx is equal to this expression right over here. This should actually be t. That's a mistake I made, but just think of it as at should be this expression and bt should be this expression right over here. So here we have that k is the largest degree of p and q in this expression right over here. So let's go ahead and compare that to what are the given differential equation that we have. So if we look at this given differential equation right over here, we see that there isn't really a variable t being multiplied by sine 11 sine 2t and cos 2t. So really the largest degree that we're going to have in this expression right over here is t to the power of 0. Thus, a of t and b of t are going to be given by this expression right over here, which is just the largest degree plus 1. The largest degree over here is 0. The largest degree in this expression right over here is t to the power of 0. We're going to add that by 1. So we're going to get that a of t is equal to a of t, and b of t is equal to bt. So let's go ahead and apply that to our particular solution. Particular solution is going to be expressed as this right over here. So it's going to be a of t times cos 2t plus b of t times sine 2t. So once we get this yp right here, our particular solution can be expressed as this. We're going to go ahead and differentiate that 2 times so we can plug it into our differential equation. So once we differentiate yp, we can get this right over here. This is the first derivative, and I went over here and rewrote it in a simpler form, and then we can go ahead and differentiate that again just to get this right over here. So this is yp, this is y prime p, or yp prime, and this is yp double prime. Now that we have this right over here, we have yp, we have yp prime, and we have yp double prime, we can go ahead and plug in these variables into the differential equation that we have written up right over here. So here we have differential equation. We can go ahead and plug in yp, or values of yp, and we get yp double prime plus 4yp equals to 11 sine 2t plus cos 2t. So we can go ahead and plug that in. Here, this right over here is yp double prime. We plug that in right over here and we get this expression, the top one, and then plus 4yp, which is going to be this bottom expression right over here. And as you can see, the way I wrote it, makes it really simple to simplify this expression, makes it really simple to eliminate like terms or add like terms. So as you can see right over here, this one has negative 4at, and this one right over here has 4at, positive 4at. So these two cancel out, and this one right over here has negative 4bt, and this one has plus 4bt. So this one and this one cancel out. This results in this expression right over here. And then all that we have to do once we get to this point is we have to solve for b, and we have to solve for a. As you can see right over here, these two, cos 2t and sin 2t, are independent of each other, meaning that the value for a is not going to affect the value for cos 2t, and the value for b is not going to affect the value of this right over here. So basically what we can do is we can get this part right over here, 11 sin 2t, we can get the 11 and set that equal to this right over here, negative 4a, which is what I did right here. So now we solve for a and b. So here's the expression, and like I said earlier, we can get this expression right over here, equal to, oh, just imagine this coefficient is a 1. We can set 4b equal to 1. Solving for b, we get 1 over 4, and then this expression right over here, negative 4a, equal to 11. So solving for a, we get negative 11 over 4. So now that we have a and b, we can go ahead and plug that into our particular solution that we wrote down earlier, which is this right over here, and we can just go ahead and plug in a and b. In doing so, I got this expression for the particular solution, this equation right over here. So now all we have to do is we can go ahead and write the general solution, which is pretty much just the complementary solution plus a particular solution. We solved for the complementary solution earlier, and we found that the complementary solution was this expression right over here, and the particular solution was this expression right over here. So our general solution is going to be this expression plus this expression. So it's going to be c1 cos of 2t plus c2 sin of 2t plus negative 11 over 4t cos 2t plus 1 over 4t sin 2t.